forget, when we get to the end of vectors, that is test number 1. Let's pencil it in roughly around next Friday. Roughly. It could be like a day before, maybe 1 or 2 days after, but approximately next Friday, Hannah. All right, let's review where we're at with vectors. So we know about vectors needing a magnitude and direction. I've talked about the examples: displacement, velocity, acceleration, and force. We've talked about the directions: north, east, south, and west. We've talked about the bearing method. We've talked about the south of east method. We've talked about the north 30 south, or sorry, north 30 east method and all that, blah, blah, blah. Yesterday we quickly got into, I never fixed this, I need to fix that. We quickly got into vector addition yesterday, and I showed you that you don't just add the numbers together, you have to remember to actually add the directions as well. And how do we do that? How do we add vectors together? Tip to tail or head to tail fashion. Okay? You learned yesterday that the answer to a vector addition question is known as the resultant. That's correct. It doesn't always have to be in red, but it certainly has to start where? Wherever the first vector started, and it has to end where the second or last vector ends, kind of thing. Can you add more than 2 vectors together? Yeah. You just keep stacking them up, tip to tail, and I'm going to explain how you can do that tomorrow in a fun little activity. We showed that, again, I showed a little bit here about how you can't add 8 and 6 and get 14. You can get anywhere between 14 and actually 2, depending on the direction, right? Remember that? Okay. And I reminded you that the order doesn't matter. Right? Just like in regular math and regular arithmetic, I think they call that the commutative property in mathematics. I could be wrong. It's been a long time since I studied mumbo-jumbo mathematics. You will require the use of a protractor and a ruler to measure the length of the resultant and to measure. Now, I never got this question the other day, but where do I measure? Like if I was to do this one here, maybe we should do this one, just as a brief example. If I were to have to find out the actual resultant, let's just say that my scale was 1 centimeter equals, I don't know, we'll go to displacement, we'll go with 5 meters or something like that. So I would have to actually physically measure the resultant with my ruler. And that looks to be pretty much right on 15, isn't it? Okay, well, we'll say it's 15. So then this would be 15 times 5, 30, 60, 75, right? How'd they do that, by the way? A little bit of mental math, right? Got to go 5 times 15. So I went 2 times 15 is 30, and then another 2 times 15 is another 30. That's 4 15s is 60. Another 15. Where do I measure the angle? This is the question that I always get. Where do I measure the angle? Do I measure it here, the start, or do I measure it way over here at the end? Right, what do you think? You got a 50-50 chance of being right. It's okay if you're wrong. Lots of people ask me the question. Where do you think? Should I measure the angle where I started? You think where we started or where we ended? How many people want to agree with Brandon at the start? Okay, what I want you to do is I want everyone to put their hand up because she's right. It's at the start. It's at the start. You don't measure where to go once you've already got there. Right? To know where to go, you gotta be at the start. Right? You gotta know where to go, what direction to head. If I want to drive to Brandon, I don't just start driving willy-nilly and eventually I get to Brandon and then turn around and say, oh yeah, I was to drive south. Doesn't work that way. I should have driven south, right? You gotta know where to go. So what angle would this be? What angle would that be? Oh, this is cool. Look at that. Where's the answer up there? I don't even see it. Do you see it? Oh, right there, 7 degrees, right there. That looks like to be a 7. Yeah, it's really tiny. So that would be 7 degrees. Now, how would you write that?
I think that's putting us 7 degrees from 0 to where you put that on.
Yeah,
Oh, okay. Are you telling me, was it you, Chris? It was you?
Yeah.
Are you telling me that, now, this is a great question. Are you telling me that you want me to measure?
Oh, that's all for you. Yeah, that.
We'll get that out later. Second. Are you telling me you want, I'll do another color so we can see it blue. Are you telling me you want me to measure this angle?
Yes. Yeah. Oh, maybe that was the one. No. Oh.
You always measure from one of the cardinal points, north, south, east, or west. You have to say of east or of north or something. You can't say of that angle we had before. You have to say of north or of east or whatever. So in fact, I skipped the part there. I did it inadvertently, but it sort of got us to a good spot. I really do want to measure 7 degrees. 7 degrees from where? From east. You have to measure from east or north or south or west. You can't measure from anything else.
Can you go northeast or northwest, or you have to go cardinal points?
You should go cardinal points. Yeah. You could certainly go north here if you wanted. You could say north 97 east, but traditionally we try to keep the number under 9, right? So sort of the generic, the simplest way to say it would be east 7, and then it would be south, right? You could also say, if you want to do the bearing method, you could say 0 is north, 97. You could say square bracket 0, 97.
The square bracket is just something that you
This is something that I do, yeah.
we wouldn't get marked.
No, this is something that I do just to, I don't know, make it clarify what we're talking about. Yeah, exactly. It's not just sort of a random number thrown in. Does that make sense? You have to measure from east, right? Like this, I hear what you're saying. You want me to measure, does it let me do this?
Yeah.
You want me to measure 28, but how would I write that? 28 degrees from where? I can't. You can't, right? It just doesn't flow. It just doesn't make sense. You got to say from, so that means you have to actually draw in a little reference line. You're going to have to actually draw in a little line like this showing east. Okay? Doesn't have to go far, just a little way. It could be north, it could be, could we have drawn the reference line down here, south? I could have said south 83 east, right? That would have been okay? I'm looking at faces. Most people are in agreement. I can see a few furrowed brows that are worried, but that's okay. We'll get there. We'll get there. You're not going to get it all the first time. How many people went home and watched this again? Because it was so much fun. Yeah, you're lying. Order doesn't matter. Now, before I forget, tomorrow you're going to do probably my favorite lesson, and I'm not going to be here. What a shame.
What?
I have to go get my head examined, Brandon.
Can't the sub do that?
Examine my head?
No, get the sub's head exam.
Oh, no. Yeah, I'm going to stay in class to send the sub to my doctor for it. Make a lot of sense. You're going to do the pirate treasure map now. If only I had scheduled it for today. If only, because you guys know what today is?
Pirate.
It's National Pirate Day. It's National Talk Like a Pirate Day. Yarr! Okay, so we're gonna have to like postpone it one day.
Go back Thursday it is.
Yes. We'll postpone tomorrow. So I prepared the video already for you. Someone has to go on Schoology and watch the link, and it will explain how it goes tomorrow. Okay? So that's what you do tomorrow. I think Mr. Stozek, someone log into Schoology, put it up there, right? Play the video. Then you can do the pirate thing. When I come back, I want all the pirate pictures up on the wall. We're going to make pirate treasure maps. And you're going to learn, you're going to reinforce that the order doesn't matter. Okay? That's all I'm going to say. Except, what's the pirate's favorite letter? R. So he really loves the sea.
That's why we come here.
It's like one of my favorite jokes, and I can always count on someone saying "arr." I can always count on it too. Awesome. Okay. Order doesn't matter. Do you remember doing the plane in the wind?
Yeah.
Okay. You may have not have drawn it, I don't know, but I wanted you to draw, right? We had like the little guy here, blue, right? And then the red. And then we had the result. So this one was longer. This one was longer because it's the tailwind. This one is shorter because it's the headwind. And this one is to the side because it's the crosswind. Okay. One last one to show you before we move on and talk more about addition. Okay. Yeah, I did here, right? Okay, so the riverboat is the last one here. So observe the motion of the riverboats below. In each case, the boat is heading across the river. In the top case, the presence of a current causes the boat to travel downstream as it simultaneously moves across the river. The result is that it reaches the opposite shore at a point downstream from where it started. Okay, now if I'm going to draw a picture up here, the boat is headed straight across. Which way is the current going? Jordan says up.
North.
North, okay. Do you agree?
Yes.
How can you tell?
This is the path of the boat.
Well, this one, for some odd known reason, this river has the current turned off. I'm not sure how that happened. But this river here, this river here, the current has to be up because look where the boat ends up, right? Okay, so the current is like that, isn't it? Right? And then here's, now the boat tries to go across, so where does it end up going? Downstream. That's the result, by the way. We put the R with the little arrow thing over top to show that's the result. Okay? Does that make sense? This is just one single vector. This is, I've added the second one in it, right? Added in, second tail right here. Good? Yeah? Okay. In the bottom case, the absence of a current means that the boat moves straight across the river. It ultimately reaches a point on the opposite shore directly across from where it started because there's no current. It's important to note that the current is what carries the boat down the stream. It is not the motion of the boat that provides its downstream motion. Okay, now for a brain buster. Which boat is traveling faster?
The one on the top. Because it has more ground cover.
Does it get there any faster?
No.
Yes.
But it travels more distance.
Well, if the current was going with the boat, then yes, but it isn't. So
It's going perpendicular to it. You'll notice I'm not giving out answers. I'm trying facially not to give you any clues because I want you to think about it. I'm going to ask the question again. Jake's going to ask the question.
well, if I have to break.
Okay, well, I'm going to ask the question again. Which boat travels faster, the top one or the bottom one?
Top one.
You're convinced?
Yes.
Can you explain why again, Ryan? Why is the top one going faster?
Because it has a longer distance to go, but it gets there at the same time as the other one that's going straight.
And you can tell that because you actually see it getting there at the same time, right? Exactly. You're pretty much right. It does travel faster. It has to, right? Like if, for example, if this is 5 straight across and the current is 1, what's the hypotenuse of that going to be?
The square root of 26.
Some number bigger than 5, right? The square root of 26, exactly. 5.1 something, right? This one is 5. It has to be faster. It has to be. How come it doesn't get there sooner? Traveling farther distance. Traveling farther distance. Good. All good.
5.09.
Thank you.
9019514.
Okay, yeah, I think I skipped ahead a little bit here. Assuming that in each case the motor of the boat propels it across the river with the same force, in which case, with or without a current, will the boat make it across the shore the soonest? Same time, right? But the top one's traveling faster. Awesome. I think that's it. Am I done? Do you guys need to draw that picture in there? Some of you may have. It's not that hard to come up with on your own. I think we're good.